Greetings, everyone. Today we're going to take a look at how to solve a quadratic equation by taking the square root. You'll want to have your notebooks, possibly a calculator, and of course a writing utensil. Let's take a look at two different types of equations. They're very similar. The only difference you'll notice is that in the first one we have x to the first power, and in the second one we have x to the second power. This changes our final steps in how we solve. Let's compare. To start solving both of these, I subtract 4 from both sides. For the second step, I divide both sides by 3. Now in this first equation, x is now isolated. Therefore, my final answer is x equals 4. But in my second equation, I still have x squared equals 4. The opposite of squaring is square rooting. So in this case, I have to take the square root of both sides to get x by itself. I now have x equals 2, specifically plus or minus 2, and we'll explain why. Let's compare these two equations again. On the equation on the left, I have 3 terms, and I can factor those 3 terms using the AC method. If I take a times c, I have -6. My b term is -1. To multiply, I'm going to use 2 and 3, but the 3 needs to be negative. I now have new middle terms of positive 2x and negative 3x and a -6. I then group my first 2 and my last 2. This is from the previous lesson, so I'm going to zoom pretty quick through this. My GCF of the second set is -3. I have the same factor of x plus 2. If I divide that out, I now have x minus 3. To solve, I set each factor equal to 0. And I end up with my 2 possible solutions, x equals -2 or x equals 3. Take a look at the second equation. In this case, it almost looks like I can use difference of squares. I have 2 terms. I have a minus sign, but if you notice, the 6 is not a perfect square. So I can't use that difference of squares rule. So in this case, my goal is going to be to isolate the x value. I'm going to add 6 to both sides. I end up with an x squared equals 6. To isolate the x, I'm going to square root both sides. And that leaves me with square root of 6, and I have to have plus or minus. The reason why is because if I was to plug it back in for x up here, if I square a positive, I get a positive. If I square a negative, I also get a positive. So I need to account for both the positive and negative solutions. So when you square root both sides, you will always have a positive or negative answer. Let's refresh our memories on when you've done solving by square roots in the past. In geometry, use the Pythagorean Theorem. A squared plus b squared equals c squared. When you solved, you plugged in a leg for A, a leg for B, and the hypotenuse for C. You solved accordingly. You subtracted to the other side. You square rooted both sides, so you've done this before, and you told us in geometry that the answer was x equals 8. Now in geometry, you didn't use a plus or minus. The reason being is because this is a physical value. It's a physical length, and I can't have a negative length. So in geometry, we wanted the very physical value of 8. In algebra, we want to account for the positive and negative. Let's review your perfect squares. A perfect square is a number that's a perfect square root. This is a list, these perfect squares, that you might want to put on the side of your notes, and on the side of homework or tests in the future. So pause this video and write down those right columns of perfect squares. Let's explore some examples. Similar to our previous lesson, our goal was to set it equal to 0, which means I'm going to subtract that 41 over to the left side. In previous lessons, we used difference of squares. I have two terms, I have a minus sign, but 3 is not a perfect square. But I do notice that I can factor this in the sense of taking out a GCF. I can take out a 3, which leaves me with x squared minus 12. If I take a look, 12 is not a perfect square either. So in this case, I'm going to set each factor equal to 0. Now 3 does not equal 0, so that GCF actually eliminates itself. On the right-hand side, I'm going to add 12 to both sides. I'm going to isolate the x by square rooting both sides. And I have square root of 12. Therefore, I also need to have my plus and minus, because if I square a negative, I would get a positive, and if I square a positive, I also get a positive. So every answer should have a plus or minus in front of it. Now we need to review and revisit reducing radicals. When reducing radicals, I often use the term good root, bad root. Good roots are perfect squares. Bad roots are not perfect squares. So let's take a look at the square root of 12. Let's start off with two square roots. I need a good root and I need a bad root. What is a perfect square from the previous slide that divides into 12 evenly? When I look at that perfect squares list, 4 is a perfect square, and 4 times 3 gives me that 12. Take your good root and simplify it. The square root of 4 simplifies down to just 2. The bad root doesn't reduce or simplify, so it stays square root of 3. And as always, don't forget to carry over that plus minus. So every radical, you need to check and see, does it reduce? Let's look at another similar example. I'm going to first isolate everything to one side so it's equal to 0. I want to do this just in case difference of squares may work. Sometimes it will, sometimes it won't. I end up with 2x squared minus 80 equals 0. I notice that I do have a GCF right away. 2 divides out of 2x squared and out of 80. Now if I take a look, 40 is not a perfect square, so I cannot use the rule of difference of squares. So instead, I'm going to set each factor equal to 0. Now 2 does not equal 0. That is not a true statement. So I'm going to cross that off. But on the right-hand side, I can isolate the x value. I'm going to add 40 to each side, and I end up with x squared equals 40. To isolate the x, I need to square root both sides. I end up with x equals positive or negative square root of 40. Now we have to check if I can reduce the radical. Let's take square root of 40 and separate it into two radicals. Take a look at your perfect squares list. What's a number that divides into 40 evenly from our perfect squares list? In this case, it's 4. 4 times 10 gets me to 40. We like square root of 4, that's a good root, because it reduces down to just 2. Square root of 4 equals 2. Square root of 10 Doesn't change. It doesn't reduce. It doesn't simplify. So my final answer is x equals positive and negative 2 square root of 10. Let's take a look at another example. I'm going to subtract 9 from both sides so that I can set this equation equal to 0. Again, I have a GCF. I can divide out at 2. And if I check, I cannot do the difference of squares because I cannot square root 2 and I cannot square root 7 to get a perfect square. So similarly, I'm going to set each factor equal to 0. 2 does not equal 0, so I don't need that. Over on the right, I'm going to add 7 to both sides. I'm going to divide both sides by 2. Now 7 over 2 does not reduce, so I'm going to leave it as a fraction. I'm going to square root both sides, and I end up with x equals positive negative square root of 7/2. Now we need to explore a second important topic of rationalizing the denominator. If you need extra help on rationalizing the denominator, just search for that on Google to watch other tutorials or find additional information. We're going to take our answer and we're going to separate it into square root of 7 over square root of 2. Now, I cannot have a radical in the bottom because square root of 2 is irrational, meaning it goes on forever. I want it to be rational. I want to divide by a whole number. So to rationalize the denominator, you multiply top and bottom by the bottom. Square root of 2 times square root of 2 is square root of 4. Square root of 2 times square root of 7 is square root of 14. Square root of 4 equals 2. So now you can see that my denominator is a whole number. It has been rationalized. Take a second look if you can reduce square root of 14. In this case, 4 does not divide evenly, 9 does not divide evenly, so I'm going to leave it as square root of 14. So my final solution is x equals positive or negative square root of 14 over 2. So two key things we need to look out for. After you isolate the x, you want to make sure that you reduce any radicals and, if needed, rationalize the denominator. Let's take a look at this example where the fraction is already in the original equation. I'm going to move that 5 over to the left side so that my equation is equal to 0. Now in this case, I don't find it very helpful to have that fraction. So if I multiply everything in this equation by 15, every single term, that will eliminate my fraction. So 15x squared over 15 reduces down to the x squared. Negative 2 times 15 is negative 30, and 0 times anything is 0. Now if I take a look, I have two terms and a subtraction sign, but 30 is not a perfect square. So unfortunately, I can't use difference of squares, so I'm going to isolate the x. I'm going to start doing that by adding 30 to the other side. I'm going to square root both sides, and I end up with positive or negative 30. Now 30 seems like a pretty nice number, so I'm going to check and see if I can reduce it. If I have square root of 30, I want to check and see if there's a good and a bad. 4, let's look through our list of perfect squares. So 4 does not divide into 30. 9 does not divide into 30 evenly. 16 does not, 25 does not, and then I'm beyond 30. So since none of these divide into 30 evenly, that means I do not need to reduce it. And therefore, my final answer is plus or minus the square root of 30. Let's take a look at one more example. In this example, I'm going to start off the same way I did the others. I'm going to subtract that 39 to the other side. In this case, it doesn't seem to help me much because if I take a look, I can't take out a common factor. I can't distribute when there's a squared involved. I can't distribute the squared because there's a plus or minus present. So in this case, I'm actually going to start by moving everything to the right side anyways. So I'm going to start fresh on this one, and I'm going to start by adding 1 to both sides. I'm then going to divide both sides by 3. I then need to square root both sides to cancel out the squared. And my last step is to add 2 to both sides. Now I can't add 2 to a radical, so I'm just going to leave it on the outside of that radical. Now notice, I can't forget when I square root both sides, I have a plus or minus. So I'm going to keep it as a plus or minus square root. Now, those 2 additional steps that I mentioned earlier, we're going to take care of both of these in the same problem. The first thing we're going to take care of is reducing the radical. If I take a look, I have square root of 40 over square root of 3. Square root of 3 does not reduce, but 40 does. 40 has a good and a bad root of 4 and 10. Square root of 4 equals 2. Square root of 10 is a bad root as it doesn't reduce. And square root of 3 remains the same. Second step, we're going to rationalize the denominator. I can't leave a square root of 3 in the bottom. So I'm going to take this expression and I'm going to multiply top and bottom by square root of 3. When I do that, square root of 10 times square root of 3 is square root of 30. Square root of 3 times square root of 3 is square root of 9. Square root of 9 is a perfect square. Square root of 9 equals 3. So 2 things. I reduced the radical, I made it a smaller radical, and I rationalized the denominator so there's not a radical in the bottom. Now I have to clarify, I can't forget my plus or minus or my 2. So my final solution is 2 plus or minus 2 square root of 30 over 3. For your homework, we have the Solving Quadratic Functions worksheet. Look for this in Google Classroom. Take your time. Some examples are a little bit tougher, but some should go very quickly. The one tip I have is be very careful with reducing radicals. Look back at that perfect squared list. You need to see if those perfect squares divide in evenly into the value you're looking at. So maybe jot that list down on the side of the worksheet so you can use it quickly. Let me know if you have any questions and get a good start on things if you're absent.